Hello, explorer. Welcome along. It's time to very quickly leave planet Earth. We'll be back before you know it. In the meantime, let's search out all those science secrets through the solar system, shall we? My name's Dan, and this is a brand new Fun Kids Science Weekly. Now, have you ever wondered why everything seems funnier when you're next to someone who is laughing?
Humans like to be part of a group, like to be part of a community or like a collective. And you're almost like 38 times more likely to laugh when you're next to someone who is laughing than when you're by yourself. So it's an extremely powerful effect.
Also, you can hear all about a super acid, and we tunnel into the strange world of quantum physics with a science legend.
We've talked about how we don't know how and why things like quantum tunneling happen. Well, there are explanations. One of them says there are parallel universes, that there is an infinite number of universes out there, parallel worlds. There's another world where you and I are having the same discussion, but I scratch one ear rather than the other.
That's Professor Jim Al-Khalili, and we'll have more from him and so much else going on in a brand new Fun Kids Science Weekly. Let's start with your science in the news. Unusual rocks discovered on Mars could contain the most evidence yet that there has been life on the red planet. The mudstones were found in a dusty riverbed by NASA's Perseverance rover that's currently roaming all around Mars, and they're dotted with intriguing markings nicknamed leopard spots, and also smaller things that look a bit like poppy seeds. Scientists think that these contain minerals linked to ancient Martian microbes, and a microbe points to life. NASA says it's the clearest sign so far that Mars once had life. Imagine that! If really soon we discover that there is life out there in the universe. That's really exciting, isn't it? Also this week, scientists have developed a superfood for honeybees that could protect them against the threats of climate change. Now, we know that bees are so vital to food production. They feed on pollen and nectar from flowers. They make honey in their hives. Sometimes there's not enough pollen, though, to keep them fed right the way through winter. So scientists have developed a superfood for the bees. And the ones that ate it, they had 15 times more baby bees that lived long enough to be an adult, if you kind of followed that. So that means more bees, which means more flowers are pollinated, which means every other animal, including us, we get more food. So this is a brilliant idea to keep the bees going. Well done, scientists. And our final story this week, a new species of dinosaur has been named after a record-breaking sailor. The species has a tall spine along its back. It looks like the sail of a ship, and it's been named after the sailor Dame Ellen MacArthur, who 20 years ago became the fastest person to sail solo non-stop around the world. It was named and discovered by Dr. Jeremy Lockwood, who joins us. Jeremy, thank you for being there. How does it feel to discover and name a dinosaur?
Well, it's really exciting. Paleontology is all about sort of solving ancient mysteries, and you go through the bones tell you a story, and sometimes if you're really lucky, you find a new animal, and that's always the most exciting thing that can happen, really. So really lovely to have been able to go back that far in time and find a species that no one has ever seen before.
So when you discover the fossil of a dinosaur down in the Isle of Wight, where there must be so many of these fossils lurking about if you know where to look, what are you looking for to find out if it's brand new to us?
Well, we go through, you need to have studied an awful lot of iguanodontian bones so that you know their anatomy very well and you know how the bones look. And then you just start working your way through. So it probably took me about 6 years of working through bones in the museums at the Isle of Wight and also in the Natural History Museum in London, where the big collections are. And eventually you learn, you think, this one's different. This is different. It's in this one, the neural spines were taller than any of the other iguanodontians that I'd looked at. And there were other changes as well to the vertebra. So we sort of thought, well, this has got to be something different. It was just too different from everything else to be just a variant of something else. So that led us to decide to call it a new species.
So tell us what we know about what this dinosaur may have been like then. What would it have eaten? How big do we think it would have been?
Well, Istiorachis was probably not too scary. It was a fairly big dinosaur. I would say probably the size of a large bull when it was fully grown. So it would be something you'd have to be a bit cautious with. But it was probably living in herds, and it was, you can think of it almost like cattle in a field. And it was a plant eater. But it wouldn't have been eating grass because 125 million years ago, there wasn't grass. It hadn't yet evolved. So it would be spending its time trying to eat really quite coarse stuff like ferns and pine leaves and bits of pine tree. So it'd be like eating Christmas trees, really. It would be really hard work. And the thing that made this one unusual was this sail going along its back.
So if we imagine this beast, and it's amazing that it's only really the size of a bull. I always imagine dinosaurs to be absolutely enormous. It's got this ridge, this sail that runs down its back, and then it's your job to name the creature. What were you thinking about when you get given that task?
Well, we like to try and name things. There's the genus name, which is the main name, if you like. So I don't know why, but it's traditional for the last few hundred years to pick ancient Greek or Latin words to name these things. So Istiorachis is the ancient Greek for sailback. So that seemed quite appropriate. So Istiorachis was named, and it was from the Isle of Wight, and it had a sail, and we have this very famous sailor living on the island. So we decided to name it after her.
Yes, so Dame Ellen MacArthur, as I say, back in 2005, sailed all around the world by herself, the fastest person to do it at the time. Now, I guess a technical question. Who do you have to tell that you've named this dinosaur? Do you send an email to the Natural History Museum? Is there a big body that you have to let know? What happens?
Yes, it's not a simple process. You need to write a description of the new dinosaur or new anything, any species. It's exactly the same. And that has to be sent to a journal. And then they send it out to world experts on this field. And those experts have to come back and agree that this is a new species. Once you've got that, you go onto a site called ZooBank, and the publishers will let ZooBank know that they are going to publish this new species and that it's been through peer review. And it's the job of the person who named it to log on and type in the name of their new dinosaur and press enter. So yeah, that's quite an exciting time when you do that.
It sounds so much fun. It's been a real joy to chat to you, Dr. Jeremy Lockwood. Thank you so much for joining us. Well, thank you very much to Jeremy Lockwood for coming on the show and telling us how he actually discovered a dinosaur. Right, it's time to get some questions on then. If you have anything sciencey that you would love answered on this podcast, make sure you leave it as a voice note on the free Fun Kids app and at funkidslive.com. I'll do the digging. I'll get a genius to come on and sort it out for you. First question this week, sent in as a message. Thank you to Betsy. How long would it take to walk to the moon? Now, this is a tough one to judge because, well, as things stand, it's impossible to do. But let's say there is a road that goes straight to the moon. Very tricky because we are spinning, the moon is spinning, the moon is also spinning around us. So it would need to be a moon that kind of stayed straight even though it was twisting and turning and wrapping around anyway. Let's say it can do that. That road would need to be 238,885 miles long, roundabout. Humans walk on average 3 miles an hour. So let's say that you walk 3 miles an hour. You don't take any breaks. You don't need food. You don't need a drink. You don't need a rest. You don't need to go to the loo. Let's say you can just walk. You walk all day and all night completely. Well, if you did that, it would take you 79,618 hours, which is about 3,317 days. So that's 9 years. 9 years, Betsy. 9 years of non-stop walking to get to the moon. We can't do it right now, and no one's ever going to do that, are they? I'm fine to be quoted. I'm fine for that to go down as a recording. The challenge is out there. It's never going to happen. Thank you for the question. Let's get on another one. This is sent in from a voice note. Romy, you're back. What have you got, Romy?
Hello, Dad. My name is Romy from Portugal and I'm 7. My question is, why do people laugh next to other people that are laughing?
Well, Romy, thank you so much for your question. Always great to get you on, Romy. Why do we laugh when we're next to other people who are laughing? Which is kind of true. I don't know if you've ever watched your favourite comedy show when you're alone, but you don't really laugh out loud, do you? But next to other people, you need to show it. I wonder why that is. Shall we find out? With a neuroscientist and comedian, well, that'll sort it, Dr. Dean Burnett, who joins us. Dean, thank you so much for coming on. How often do you reckon you laugh a day?
Oh, dozens of times, I think. I actively try and find things to make myself laugh because, it's a very enjoyable experience and also very cheap and easy. So, nothing wrong with that.
So before we get right into Romy's question, as a neuroscientist, what do we know about why laughter is good for us? Is it doing anything to our brain?
Yeah, laughter is a very complex process, and it's actually something deeply embedded in the human brain. Humans aren't the only species that laugh, like lots of species do, but even rats, if you tickle them, but it's so high-pitched you can't hear it, which means it is someone's job in a lab somewhere to tickle a rat all day, which sounds like a good deal if you're into that sort of thing. But yeah, it's a very pleasurable experience. It's also very, very active, like when we laugh, it's not like if you feel angry or sad, it's all like internal. But when you laugh, it's a big open sound. It's a big gesture and you almost can't control yourself. So yeah, there's a lot of different neurological processes happening when we laugh. And a lot of it to do with the fact that humans are social. We are a friendly species. We like to hang around other people, and laughter is a big part of forming those bonds and maintaining them.
Well, so to Romy's question, and a very old phrase, laughter is infectious. We do laugh when we're next to other people who are laughing. Why is that happening, Dean?
Yeah, definitely. Very good observation. Very valid. I think Professor Sophie Scott at UCL, she's like the lead on this, but she's done studies which show that you're almost like 38 times more likely to laugh when you're next to someone who is laughing than when you're by yourself. So it's an extremely powerful effect. And like I said, it's a bonding thing. It's humans like to be part of a group, like to be part of a community or like a collective. And when someone laughs and you want to join in, you're sharing the pleasure, you're sharing the enjoyment, and you're sort of like showing we are on the same page, we're looking at the same thing. And that sort of really helps us. It's a very strong, like a relationship reinforcement thing. It's to show we're all here, we're all doing the same thing, we're all looking at the same stuff, and we're all enjoying it. And the human brain really likes that. We really like being part of a collective, and laughter is one of the best things for doing that. So yes, laughter is contagious, which is why, like I say, things can be really funny when you're part of a group. When you're by yourself, they wouldn't be. Like even like when you're hanging around with your friends, and then someone says, "Hey, remember that time when someone tripped over slightly?" and everyone starts laughing. You wouldn't, by itself, that's not a really funny story. But when you're with other people, it is, because that's how powerful this effect is.
What's really interesting, I think, is that we don't know that's why we're doing it. It's not like we can understand a thought that says, hang on, I'm with my friends, I want to let them know that I find this funny, so I'm going to laugh too. It's all happening without us knowing, Dean.
Yes, absolutely. That's actually one of the problems or one of the challenges of researching it, because we have all these, super advanced brain scanning technology now to show like the activity in the brain. But evidence suggests that the processes which underlie laughter, they happen so fast in the brain, they're so rapid that even our best scanners can't keep up with it. It happens too fast for the scanners to recognize. So that's how quick it happens. Like it's faster than thought. So we just start laughing because something funny has happened. Our brains recognized it, and then it's so fundamental, it's so deep that our thinking brain can't keep up with it. So yes, it happens without us even realizing. So it's lots of different processes at work without us even being aware of them.
And Dean, I know that you, as well as being a neuroscientist, a comedian as well, do you find when you're up on stage that you understanding this helps you talk to an audience better or know how to get a laugh better?
In certain situations, it can help, but other times it means you really overthink things. And like you're trying to sort of like, right, if I say this now, I'll coordinate the laugh to start here and it'll spread. It's like you're trying to sort of, coordinate an army in a video game rather than just trying to be relaxed and funny. And that does tend to work against you a bit when you're trying to just be chill in front of people who are there just have a good time.
Well, listen, Romy, that's why we laugh when we're next to other people who are laughing. It's social bonding. We're letting them know that we find what they find funny too. And we can thank Dr. Dean Burnett for coming on and helping us out with that. Thanks, Dean.
No problem at all. Anytime.
Now, remember, you have a chance to come and explore the universe with me. This podcast, the best podcast in the universe, it's on tour. We've played all around the UK. The shows have been awesome. So many incredible experiments. We've had Dangerous Beasts. It's all going on. And we've got more shows through the autumn too. If you're listening on the Saturday and you've got nothing to do on the Sunday, well, come along and see Fun Kids Science Weekly live in Swindon. We've got huge snakes. The biggest snakes that we've had on the tour so far will be there on Swindon. We might have a little snake off if that can happen. We've got brilliant experiments, slimy things that go bang. I will teach you how to make a lightsaber, and you can get your hands on something from outer space. So that's happening. And then in a few weeks' time, we're playing in London, and we've got loads more shows happening all year. And I'd love you to come along and help explore the universe with me. We'll say hello. You can get your hands on a meteorite. We'll do high fives, photos, all of that stuff too. So grab a grown-up. You can get your ticket. Come along and see our live show. Find out more, funkidslive.com/tour. For this week's Dangerous Dan, where we search out the weird, the most unique and strange and deadly things in the universe, we're headed into the lab to see the world's strongest known liquid superacid. It's an amazing title, isn't it? A superacid. You know an acid? That's a substance which burns. When you eat something that tastes acidic, it can be sour and bitter. Loads of the stuff that you grown-ups might use to clean the house, well, they've got acids in. Most liquid acids burn a little, but fluoroantimonic acid burns a lot. It's a superacid. It's over 1 billion times stronger than sulfuric acid, which is one of the most dangerous ones that we use day to day. So it's super strong, and it's a superacid. It can eat things that can't normally dissolve, like glass. Now, a tiny drop of this liquid on skin, it wouldn't just burn, it would rip straight through the flesh and then bubble and boil with the water in your body. It's normally colourless, it can be yellow though. The fumes it makes are toxic. When it gets into contact with organic matter, that's the dead stuff in the soil decomposing, it explodes. Now, it's not really made naturally. Small amounts can be found near volcanic vents in the ocean, and only a few laboratories in the world can handle it. It takes very specialised equipment. We use it to dissolve big, thick rocks, and that's really it. It's strong, it's a dangerous, deadly superacid, which means fluoroantimonic acid goes straight onto our Dangerous Dan list. This week in Battle of the Sciences, where we try to discover once and for all what is the greatest science in the universe, we are looking at something that I think might just blow your mind. It'll take a lot to get your head around it. So to explain it, well, we've gone big with an absolute science legend, published many books, was once president of the British Science Association, been all over the telly. We've got Emeritus Professor Jim Al-Khalili from the University of Surrey. We're talking quantum tunnelling. Jim, thank you for joining us. You have 1 minute to tell us why quantum tunnelling is the greatest science, and that minute starts in 3, 2, 1, go!
Right. Well, first of all, quantum mechanics is the most powerful, the most accurate, the most important theory in all of science, because quantum mechanics describes how atoms behave, the particles that make up atoms, how they behave. And it's very, very different from the world that we see around us. And it's also very, very strange. So one of the things that happens down in the quantum realm that we don't see in everyday world is what's called quantum tunneling. Basically, particles like electrons can pass through force fields, energy barriers, like a ghost going through a wall. It's as though I throw a ball at a brick wall and it disappears from one side and reappears on the other. If you saw that in everyday life, you think, well, there's a trick. It can't really be true. In the quantum world, quantum tunneling happens all the time because particles also behave like waves. They leak through force fields, disappearing on one side, arriving on the other, like magic.
Whoa, I mean, it sounds like magic, and I must say, Jim, I've spoken about so many different types of sciences and fields doing this, but something that's happening at such a small level, it's so hard to get your head around it. What do we know about why this is happening? Why are these tiny little particles being able to pass through a force field?
Okay, well, the honest answer is no one really knows why it happens. This year, 2025, we're celebrating the centenary of the birth of quantum mechanics. All the mathematics was developed and sorted out back in 1925 by a whole bunch of physicists who worked really hard trying to understand what was going on with atoms and the interiors of atoms. It seemed to be very strange. They didn't believe it. They carried out experiments, and it turns out that is actually what's going on. In fact, because of quantum mechanics, I can talk to you on via a computer because quantum mechanics tells us how electronics works. It tells us it gave us the laser, it gave us LED lighting, it gave us the transistor. All modern electronics rely on quantum mechanics, so it works. But how and why? All we can say is these particles, these things that make up atoms, behave in a rather fuzzy way. You can never know exactly where they are or what they're doing. So they might appear on one side of a force field and suddenly disappear and reappear on the other with a certain probability. It happens. We see it all the time, but we can't really get a picture in our heads as to how that happens.
So if this is happening all the time, we know it's happening, but we're not sure why. What types of experiments are we doing to try and discover actually why and how this is happening?
Well, first of all, the place where it happens most obviously, we don't have to do an experiment. It's happening inside our star, in the sun. The reason the sun shines, gives off heat and light and allows life to exist on Earth is because inside the sun, atoms of hydrogen are quantum tunneling together. Basically, particles are passing through this force field like magic in order to stick together, turning the element hydrogen into the element helium. And when that happens, that's called thermonuclear fusion. And when thermonuclear fusion happens inside stars, that's what allows stars to shine and give off heat. So we know if quantum tunneling weren't happening, the sun wouldn't be shining. Now, we can do smaller experiments on Earth to see how and why that's happening. And one of the most exciting things going on at the moment is that scientists are trying to build quantum computers. Now, quantum computers rely on these sorts of weird ideas in quantum mechanics, but we need to understand how this happens if we're going to develop these new technologies. We're working on it.
It's such a huge concept, Jim. And I said at the start, this might be something that blows your mind. So if someone is listening, and actually it can almost make perfect sense to them, and they want to be the future of quantum mechanics, tunneling, quantum computing, what type of things would they need to be trying to specialize in now so they can do that in the future?
Well, it depends. So when you get to become a quantum physicist, you can either be doing the equations, the maths. So you have to really enjoy doing maths. You don't have to understand the maths yet. That comes with training, but you have to be able to enjoy doing maths, doing the algebra, doing the geometry. But you can also do the experimental side of things, which means you should enjoy tinkering with instruments in a laboratory, wiring and things like that. So it's not just one skill that you need. The most important thing is to be curious, to be thinking to yourself, how can this happen? I need to know. If you have that attitude towards mysteries of the quantum world, you're basically halfway there.
Jim, we always finish these chats in exactly the same way. Let me throw you forward years and years and years now. Towards the end of your complete career as a scientist, what's the one question that you really want discovered? What do you want to know in your field?
Oh, okay. Well, this has to do with quantum mechanics, funnily enough. You see, the theory works, we've talked about how we don't know how and why things like quantum tunneling happen. Well, there are explanations. One of them says there are parallel universes. It's called the many worlds theory. One says that the whole universe is interconnected instantaneously. And that's called Bohmian mechanics. There are like half a dozen different ways of explaining it. What I would like to know before I die is which of them is the correct way of explaining what's happening in the quantum world. These are called the interpretations of quantum mechanics. And for 100 years, physicists have been banging their heads against walls trying to understand.
What's the most interesting explanation for you right now?
Well, the most interesting one, I'm not sure I fully believe it yet, it is this many worlds interpretation, because it's the cleanest way of explaining things. But it does mean that there is an infinite number of universes out there, parallel worlds. There's another world where you and I are having the same discussion, but I scratch one ear rather than the other. So if you're happy to believe there's an infinite number of parallel realities, then this many worlds interpretation is the best way of explaining quantum weirdness. But the weirdness doesn't go away.
Wow, you've done a great job in explaining quantum weirdness, and quantum tunnelling is that first on our list for the Battle of the Sciences. Professor Jim Al-Khalili, thank you for joining us.
My pleasure.
Thank you for Jim for coming on the show. Absolute science legend on this podcast. That's absolutely amazing. Had so much fun chatting to him. He was talking all about quantum tunnelling. What happens when we tunnel in the ground? See, we're making the link there. We're catching up with one of our good mates, our Earth genius, Charlie Crow, learning all about digging and tunnelling in this series, heading to a quarry. Now, they might seem like a life-size version of Minecraft, but you can hear with Charlie that that's not the case at all.
Charlie Crows, stay safe. Stay out of quarries.
You alright, mate? Charlie Crow here. Now, I see all sorts as I fly about, and one thing that really ruffles my feathers is seeing kids playing in quarries. It's so dangerous. Oh, don't do it. So, what's a quarry when it's at home? Well, they're massive places where rocks, gravel and sand are extracted and processed to make aggregates. Aggregates are used to build things like our homes, roads and hospitals. Chances are, even your school. Now, they might look like fun places to explore and play, but they're not. You've got falling rocks and steep drops, and if you get into a spot of bother, well, there may be no grown-ups around, and mobile reception might be very poor. I know lots of you kids like playing Minecraft, digging with pickaxes, making tunnels and caves. Well, because quarries can have sandbanks or big piles of sand and gravel, some kids think that they'll try out their mining skills for real. These kids are very, very stupid, even more stupid than a pigeon. The warning signs and fences are there for a reason. Those massive piles of sand can collapse on top of you and your friends, burying you in seconds, and you won't be able to dig yourself out. Game over. Kids have been seriously hurt or even died playing in the sand in quarries. Sometimes you find sand piles near a wharf, in a railway yard or a building site too. None of these are ever safe places to practice your mining skills. Oh, it gets me in such a flat. You want to practice your digging skills, then go find a safe beach or even get out in a garden. And if your mates have the bright idea to go mining in a quarry, explain the dangers to them. It could save their life. So stay safe, stay out of quarries. Gotta fly.
Charlie Crows, stay safe. Stay out of quarries is supported by the Mineral Products Association. Find out more at funkidslive.com.
You can hear more from Charlie wherever you're listening to this podcast. Just search for him. We've got brilliant geniuses there too. You can find them on the free Fun Kids app and at funkidslive.com or on Google, Apple, Spotify, all of those places. Get your ticket to come and see Fun Kids Science Weekly live through autumn. funkidslive.com/tour, and on the website you can send me a question for a future episode. Fun Kids, we are a children's radio station from the UK. You can listen all around the country on our app on the website. And if you've got a smart speaker, wake it up and ask it to play Fun Kids.